Hello, welcome to a new video by LSX Flashing and Tuning. In this video I'm going to discuss the parts needed to rebuild a 4.3 liter GM Vortec motor used in a marine application. This video is the start of a new series on how to rebuild a Mercruiser 4.3 V6, in that the last series I started with a motor that was in decent shape. It didn't need a lot of machining, the bores were good. I had the crank repaired, put in new bearings, new rings, honed it, and then you saw in the video that I finished the build and then I put it back in the boat. This video series is going to be different. It's going to be the second one of rebuilding a 4.3 Mercruiser V6, but on this series I'm starting from scratch. The block is a truck engine that's being bored out and honed. It's going to get new oversized pistons. It's going to get a lot of new parts. I'll call the bare minimum of new parts. You might need more than this, but I'll discuss that when I get to it. But this is the bare minimum of parts I think you need to rebuild a Mercruiser 4.3 V6. So let's get started. First of all, discuss the pistons. Like I talked about in my other video on 5.7 Mercruiser rebuild, where I discussed pistons. These pistons are, let me get the part number here. This particular part number is H640 DCP. Come on, camera, focus. It won't focus too well, but anyway, these parts are H640 DCP 030, meaning they're 030 oversized. This same piston has part number H4.3 DCP, and that's used in the V8 application. This is a V6 set. You'll notice the box is a smaller box, so it's the V6 set. That's why it's got H640 on it. However, you can buy H4.3 DCP or 640. They're the same pistons, so if the V8 set happens to be cheaper, buy it and get you 2 free pistons. In case one of your pistons is messed up, you'll have 2 spares. So in that case, always check H4.3 DCP first when you're buying a set of V6 pistons, because you'll get 2 extras possibly for a cheaper price or for the same price. And I don't know why, but these pistons price varies widely from week to week. So anyway, I just wanted to let you know about the pistons. Other than that, these pistons are also, now these are the pistons you'll, if you go on Rock Auto and look up 2002 Vortec V6, the 2002 all the way up to 2014, I think is the same for the V6 model. But if you look at Rock Auto 2002 V6 pistons, you'll see it says H640 DCP. So these are the proper pistons used in the Vortec engine based on Rock Auto. Like I discussed, in the V8 version, they switched to a, I think it's H815 or H857, I'm not sure. For the V8, it uses metric size piston rings. This particular brand, or this particular model here, the 640 DCP and the 423 DCP, using an imperial size piston ring. It's 5/64 for the top and second ring, and then I think 3/16 for the oil control ring. And that's the only difference. So why pay more for a piston with the exact same characteristics, other than the ring, the width of the ring, which is very minor, and pay about $100 more? So, but in the V6 version, H640 DCP is the part number. And again, H4.3 DCP will work. If you look on the top of these pistons, as a matter of fact, I've got one right here. This piston happens to be out of the V8 box. You can see it's stamped with the same number, H640. Let me see if I can get this thing focused. Nope, this camera won't focus for some reason. Anyway, trust me, it says H4.3 DCP / H640 DCP 030. So that particular piston, like I say, in this box will have the same dual part number as used for both V8 and V6. Sorry about my messy shop. I've been tearing motors apart like crazy. But anyway, I think that's all I need to say about the pistons. Again, check the 2 part numbers, get the price for V8 if you want to save some money, or partially get 2 extra pistons for the same money, and you'll come out better. So let me put these down. Okay, moving on. So after you get your pistons, or check your pistons, by the way, if you're building one motor, I build probably 3 or 4 motors a month. If you're building one motor, you'll always want to take the pistons to the machine shop with your block when you have it bored. And the reason is, apparently pistons, when they manufacture them, the tolerances are not all kept tight. So one piston might be a little larger than the other. So when they measure these pistons, they will cut the bore to fit that piston. So, and if you do that, when you get the pistons back, they better be numbered for the cylinder that they came out of. Otherwise, you wasted your time. So the machine shop has to put a number on the piston so that you know which bore it goes back in, because that bore was cut for that piston. So that's the last tip I want to say about the pistons. So moving on to rings. Moving on to bearings. So this is the main bearings. I had the crankshaft cut 10 thousandths under on the mains and 10 thousandths under on the rods. So these are your main bearings. It's the same part number using my last build, 5085 M10. So these are 10 thousandths. The bearings are actually undersized because, let's see, I guess oversized because the crank's been cut undersized. So these are 10 thousandths bearings. For my rod bearings, I sent them in two different size boxes, but that part number is, see if I can get it focused, 1020 CP 0.25 millimeter. And they're all 1020 CP 0.25 millimeter. These are your rod bearings, or 6 of them, and again, 0.25 millimeters is 1/10 of an inch. No, it's 10,000th of an inch. So these are 10 thousandths smaller, just like the mains are. And that's the rod bearings. And by the way, these are the tri-metal. They're called tri-metal. They've got a steel, lead, copper combination for the bearing, and they're known for being a bearing that handle loads better than the bimetal, which are aluminum bearings. Apparently, manufacturers use aluminum. I just tore down this LS motor about 2 months ago, and it had aluminum bearings in it from the factory. So apparently, aluminum is okay too. But anyway, there's your bearings, mains, and rods. Moving on, the 4.3 V6, and I've got a block here. See if you can see it there. The block is under that pile of trash right there, but which came out of another motor I tore down 2 days ago. You can see that 4.3 V6 block has got 2 plugs. There's one there and one there. That one's for your camshaft, and that one's for your balance shaft. So the 4.3 V6 has a balance shaft. The V8 does not have a balance shaft. So when I was looking through the expansion plug kit that I bought for the V6, which is melting, let me see, MPE 185 BR. BR stands for brass. So I was looking through this kit the other day, and I noticed it only had one of these steel expansion plugs. That's your camshaft plug. It did not have the balance shaft plug in it. So I went back online to Rock Auto and found out that I needed to buy this. So this is a box of 10. They don't sell them individually. It's a box of 10 expansion plugs, steel expansion plugs, and these are for the balance shaft plugs. I think they're the same as the camshaft. You can use them either or. But I bought 10 of them in a box. So the part number is 555-080, and this is made by Dorman. So these are for the balance shaft, and that one's for the camshaft. So you're going to need one of these. Too bad you had to buy 10 of them, but they're 86 cents a piece, so it cost me $8.60 for the whole box. So you'll need that for your balance shaft. And then these are your expansion plugs for your block. Most time when you take a block to a machine shop to get it prepped up and bored, they knock out all the plugs. They knock out all the oil galley plugs, unscrew the things. So you see in this kit, you got threaded in plugs there, 1/4 inch pipe thread there, 2 more here, and then these are knock-in plugs here. These are oil galley plugs, and then there's another. That's not a 1/4. That looks like 3/8 pipe plug there. So you'll have oil plugs. You'll have water expansion plugs. You'll have all kind of plugs in this kit. So when you take the block to the machine shop, they will knock all those plugs, unscrew the plugs, knock them out, whatever, get the block absolutely cleaned out, so that when they put it in the hot tank to clean it, the cleaning chemical goes in all the passages to clean it out. So when you get it back from that machine shop, or when they get it out of the hot tank, if you provide them with the plug kit, they will put them in for you, I guess for a fee. Otherwise, you can do it yourself. So when I go down there, I'm going to ask them if they want to put them in for me, or do I need to do it myself, and what they charge. But I can do it myself. It might save me some time if they did it, especially if they charge a fixed fee for cleaning the block, and it includes putting all these plugs back in. Then of course I'm going to take the plugs back down there and have them do it because it's part of the fee. Something I'll have to ask them later. But anyway, that's the plugs. So next, like I was saying, you got your camshaft. So when you put a block in a hot tank, when I say hot tank, it's a hot chemical tank that cleans off the cast iron block. The bearings in that cast iron block for the cam will be damaged. They'll be damaged by the chemical. So you have to replace your cam bearings. If they're not completely gone when you get it out of the hot tank, the machine shop will knock them out for you. And then you have to put the cam bearings in with a special tool. It's called a camshaft bearing driver or installer. I have one. I think I paid $125 for it from Lyle Tool Company. When I get the block back, I'll show you how I put these cam bearings in. But this part number is 1855M. These are cam bearings for a Vortec V6. Now, you have a balance shaft on the V6, and the balance shaft part number, actually this is the rear bearing for the balance shaft, not the front. And it's a 3204DR. There you go, I just got it to focus. How about that? So, this part number is 3204DR, and it is the balance shaft rear bushing or rear bearing that goes in the back of the block. I'll have to knock that in too with my cam bearing installer. You don't need a front bearing because the balance shaft has a ball bearing that's pressed onto it. And so from my experience, that ball bearing never wears out. It spins freely from when I take these things apart. It spins freely just like it was brand new. So unless you can feel some roughness or it tends to slow down and has friction in it, I wouldn't replace it. You have to press it on and off, and it's really not worth replacing. So there's your cam bearings. Next is the timing set. This is called a timing set. This one's for a 4.3 V6, and it's Chloe's part number C3212. And again, I either got these parts from Summit Racing or Rock Auto. More than likely Rock Auto. Rock Auto to me is a much faster way to get parts. Their website is super efficient at finding part numbers. But I also get stuff from Summit because sometimes their price is better. But I hardly ever use Jegs because Jegs always seem to say, we'll match the price, but they charge $100, $200 more for the same thing. You have to go find out what the other price is and come back and email them and say, hey, Rock Auto's got it for this. Will you match it? And they say, yeah, sure. But to me, that's a game. I'll just go to Rock Auto and buy it if they want to play that game. So that's the timing set. And the timing set, by the way, includes the crankshaft gear, the chain, and the camshaft gear. You need all three of those when you put it together. And by the way, like I said, I don't replace major parts like camshafts, piston rods, crankshaft. I have the crankshaft machined if it needs it. But the camshaft typically doesn't wear out. I don't replace lifters unless they need it. Here's a set of lifters right there from V6 right there. I clean them up, and if they're in, as long as the, let me take this one out here. Now this one is toast. You can see that is a bad lifter. It's pitted right there. So this lifter is something I would discard, not use. But a lot of them are in great shape. You can take your finger and spin this bearing. See, like that. But this one's toast. You can see the pitting right there. This is junk. But if the lifter bearing is good and the roller spins freely, I'll reuse it unless I know that particular lifter was collapsed. There's two things go wrong with the lifter. It either can collapse into the hydraulic mechanism inside can collapse, or the bearing or the roller can be bad. So as far as the collapsed lifter, I guess you won't know till you put it together. But I guess it depends. If they generally look like they're in really good condition, more than likely they didn't collapse. So that's the lifters. As far as the cam goes, this is a junk truck cam. It came out of one of my truck cores. You can see that low right there is kind of pitted right there. I don't think this one can be saved. It might, But the reason I bring it up is because obviously I wouldn't use it as is in a new motor or in a rebuild, but there's a company in Washington State called Delta Camshafts. You can look them up on the internet. They can take this truck camshaft and regrind it and regrind it to marine specifications for 4.3 V6. So don't throw away your used camshaft. You might could get it if you don't have a marine camshaft. You can have it reground by them. It costs about $85, $90 plus shipping to have this cam reground to a marine spec. A brand new one probably sets you back $300 from these marine parts, and marine repair shops tend to cost twice as much as a standard car part. I don't know what it is about marine. They like to keep things kind of mystical and secret so they can charge you more money. But really, there's nothing really a whole lot mystical about it to me. So that's the camshaft. Next, we'll talk about, this is the head bolts, and these are the bolts you'll need to put the heads back on. In case you're new to building motors, the head goes right here on this surface. This is the top of the block. This is a V8, but a V6 would not have that last cylinder on there. But your cylinder head goes right here, and the head bolts go in these holes right here. Now this is a LS motor, so it's a little bit different than a Vortec V6, but the concept's similar. So you'll have head bolts that go in these holes here. So these bolts are called torque to yield. That means when you put them in and turn them, you don't turn them with a torque wrench to a certain torque. You turn them with this tool right here, which is called a torque angle gauge. And it's got this kind of like stop on it. It's a 1/2 inch drive, and it goes between your torque wrench and your socket, 1/2 inch drive socket. And what you do is once you initially tighten these bolts down a little bit, that's 20 on a Vortec V6 is 22 foot-pounds the initial torque on the first stage of tightening. For the second stage, you tighten them to a certain amount of degrees. It could take 100 foot-pounds. Of course, it probably won't because you'll break the bolt, but it doesn't matter what the torque is. It matters how much you turn them. So from memory, the Vortec V6 is, I think, 75 degrees for the longest bolt, 65 degrees for the medium bolts, and 55 degrees for the shortest bolts. So depending on the length of the bolt, you turn them a certain amount of degrees, and irregardless of how much torque it takes, you turn them a certain amount of degrees. Now, I found my experience is that the torque is generally less than what it used to be when it was done by torque. For example, you might tighten head bolts 75 foot-pounds in the old days, and these new torque yields only take 60 foot-pounds or 55 foot-pounds. But the goal is that you turn it a certain amount of degrees rather than put a torque on it. And I'll do a whole nother video on why, but it has to do with the metallurgy of bolts and how they work. The bottom line is you get a more consistent clamping force and less error with torque to yield bolts than you do with torque bolts. So that's the part number ES74034, and these are torque to yield bolts for a Vortec V6. And you need 2 boxes because there's 2 cylinder heads. So I've got 2 boxes here. Same part number. And these generally run, I think these run about $15 a box from memory. I don't know exactly what the cost is, but $15 a box sounds about right. All right, so moving on. The last thing is the gasket set. Now this is an automotive gasket set. The part number is 260-1738. And this box is a full gasket set and contains all the gaskets you'll need to rebuild a motor. Obviously, it has the gaskets for automotive applications also. But the big controversy is I've been called out for using automotive head gaskets instead of marine head gaskets. I'm still doing a little bit of research on that, but most of the boats I build are used in fresh water. So you're not going to have a problem using fresh water. You got fresh water in a car engine with a little antifreeze in it, but fresh water is not going to damage this head gasket. Now, if it was salt water, it might be a little different story, but I'm still going to research into that and find out. But like I say, your head gasket is really not, the only part water touches is around the bolts right in here. There's no water in the cylinder, so there's no water around this ring here. The only place water is going to touch the head gasket is right around each bolt because, excuse me, not the bolt, but the water passage. This water passage right here, not the bolt, but the water passage. So wherever the head gasket, whatever water is going from the block up into the head, that head gasket is sealing that gap. So that's where water will touch the head gasket. And honestly, it's just like super, super, super thin, and it's made of composite material, paper, or whatever, and maybe a little bit of steel in there. But again, I just don't see it being a huge problem, except maybe 30 years down the road if you run it in salt water or something. But I'll look into that a little more and keep trying to figure out the answer to that. But in the meantime, back to the gasket set. The head gaskets are in this set for automotive application. Marine head gaskets are about $50 a piece, and this whole gasket set only cost me about $70. So I just think it's silly to use marine grade head gasket. I think it's a racket personally, and I just explained why. But I'll dig into it and find out if there's a valid reason for using marine head gaskets or not. All right, so that's about it. Oh, I skipped piston rings. So back to your piston rings. This set is for the H4.3. Remember, this is like I said, the pistons were H4.23 DCP for the V8, and this is the piston ring set that goes with the H4.23 DCP, and they're 030 obviously. Now you might ask, why have I got a V8 set when a V6 set is a different part number that goes with the H640? Well, the reason I buy the V8 set is, one, they're cheaper. I don't know why, but they're cheaper. And two, you get 2 extra sets of rings in this box compared to a V6 set. So for less money, you get 2 extra sets of rings. So if you were to damage one set of ring, you've got 2 spares. Again, makes a whole lot more sense to buy the V8 set than the V6 set. So that's the rings. I believe I've covered everything on a new building a Vortec V6 from scratch. And if I can think of anything else, or if I missed anything, I'll put it in the description or the comments. But that's about it for building a 4.3 Mercruiser V6 from scratch. And this will be the first video in a new series on building an engine from the ground up, brand new, basically the engine block that's been machined, come back from the machine shop ready to build. And it's going to be a lot more involved than my previous series on rebuilding a 4.3 V6. So stay tuned and subscribe if you appreciate my work. Thanks for watching.